We'll discuss how much artificial intelligence and machine learning have changed the landscape of science. And to discuss with us today, we have several guests. I'd like to present them. So we have Professor Trilce Estrada from University of New Mexico. Hello. We have Jibo Sanyal from Oak Ridge National Laboratory. We have from UK, Nikos Konstantidinis, University College of London. And then in Geneva, on the stage, we have Professor François Fleuret from the Computer Science Department, University of Geneva. And who will moderate this discussion, Professor Maria Girone from CERN. So she's a high-energy physicist, and she's expert in scientific computing, also in charge of the CERN Open Lab strategy for AI and HPC. So Maria, please go ahead.
Many thanks, and good afternoon, and welcome everyone to this panel. So as Bastien was saying, AI is everywhere. We use it a lot in science, but actually we use it every day. It's also very importantly changing our directions in emerging computational disciplines. So today we are going to discuss what is the impact of all this in science and in our life. And for this panel, we will be discussing three key areas: AI for discovery science and how it compares to traditional methods, sustainable AI and how it can be evolving to be more green, and the future of AI and what we can expect. But before starting, I would like to say a few words about our distinguished panelists, starting with Professor Trilce Estrada. She's Associate Professor in the Department of Computer Science at the University of New Mexico and Director of the Data Science Laboratory. Her research interests span the intersection of machine learning, high-performance computing, big data, and their applications to interdisciplinary problems in science and in medicine. She has received several awards, and she is a reference leader and a PI from NSF and university programs. Here we have Professor François Fleuret. He's full professor and head of the machine learning group in the Department of Computer Science at the University of Geneva, and adjunct professor in the School of Engineering of the École Polytechnique Fédérale de Lausanne. Professor Fleuret is the inventor of several patents in the field of machine learning and co-founder of Neutral Concept SA, a company which is specializing in the development and commercialization of deep learning solutions for engineering design. His main research interest is machine learning with a focus on computational aspects and sample efficiency. Nikos Konstantinidis, Professor of Experimental Particle Physics at the University College London. He has been involved in the ATLAS experiment at the CERN LHC for the past 2 decades, and is an expert in real-time event filtering, a pattern recognition for reconstruction of charged particle trajectories, which are, by the way, 2 of the most data and CPU-intensive challenges of the LHC experiments. And since 2017, he has been leading the STFC Center for Doctoral Training in Data-Intensive Science at UCL, which aims to foster cross-disciplinary interactions and industry-academia knowledge exchange in novel AI techniques. Last but not least, as we always say, Jibo Sanyal serves as the group leader for the Oak Ridge National Laboratory's Computational Urban Sciences Research Group. His work falls at the intersection of high-performance computing, extreme-scale data and analytics, modeling and simulation, visualization, scalable machine learning, sensor and controls for building both research and operational systems focused on complex urban systems at local, regional, as well as national scales. He is an IEEE senior member and award recipient. So, despite the fact that the panel is in this hybrid mode, which, by the way, is at least a step in the right direction, let's try to keep this panel and this discussion as interactive as possible. So please ask questions to the panelists. We are here to learn from them. Of course, to get started, I have prepared some questions, but there will be many moments in which we will be looking at questions from the audience. So please don't be shy. So we get started, and the first topic that I would like to bring to the panel is can we bypass the traditional ways of intuition, hypothesis-driven models, and instead use AI? Or in other words, what are the technical challenges to using AI and data to generate predictions for complex science problems? So I would like to invite Gibo to start on this question with us.
Sure. So when I think of the traditional hypothesis-driven way to go about the business of science, and then look at what we're trying to do with AI lately, there is an inherent belief in many of us that AI will get us some answers that wasn't traditionally possible. And to a certain extent, that's true, because AI lends itself to be applied to very unstructured data streams. However, in my experience, I've found that ultimately, at the end of the day, if you want a smart solution, it's about the intent of what we want eventually. One of my close collaborators, the smart city director for the city of Chattanooga, Mr. Kevin Comstock, he actually posted on LinkedIn yesterday, what makes a smart city? Is it a smart trash can that tells you that, hey, I'm full? His argument is that if we enable another level of decision on top of it that allows a certain level of benefit at scale, at that point, we're getting to some element of smartness. And we're still really scratching the surface of this. I feel like a lot of the things that we end up doing, particularly we ask a lot from our AI approaches. We ask a lot and end up always going back and asking the question, how does this benefit us? Which in my mind is this intuition that there is a certain problem and we are trying to solve it, which is a form of a hypothesis. So yes, AI allows us to apply techniques without, we should put full regard to it. However, it allows us to apply those techniques in places where we have not been previously very successful with traditional approaches. However, at a higher level, we need to know what we want to accomplish. And that's my argument there. Thanks.
Thank you. Francois, would you like to add your perspective on this?
Yeah, so I would say, even though often we see AI as a way of doing inference when we don't have a model, so this is generally how it's sold. It's like if you have enough data, you are able to, without a model of the underlying physical phenomenon, you are still able to do inference and prediction. I was thinking about this, preparing this panel, that the actual example where AI shines for physics or for real science is when we actually already perfectly understood the phenomenon, and it's either to do simulation very fast, simulation that we already know how to do, or to compute inverse problem, to solve inverse problems that are so intractable that we are not able to solve them. So I would say my perspective on the current situation is that maybe asymptotically we would find ways of using AI to actually replace the scientific process, so to, instead of devising laws that we understand and then doing a prediction from it, for still a while it will be more as a way of speeding up things, but speeding up in such a way with so much improvement of speed that it makes things. The protein folding is a good example. So protein folding is something where you know what happens, but you're not able to do the folding. You are just able to check that the folding works. So I think for a while, where the best use of AI for science is we already know the science, we just use AI to do it fast, to solve the problem fast in the context, in the formulation that we already understood. Spectacular as what we hope to achieve.
Thank you. I was seeing earlier on Trilce was nodding at what Giba was saying. Anything to add? Or maybe not?
Yeah, just to say that definitely, I mean, scientists should not go away from the scientific method. So AI is a very powerful tool, but we really do need to know what are we looking for. Otherwise, there is a quote that I really like, and it's something like, if we beat the data to death, it's going to confess to anything. So if we start with without an hypothesis, we are going to achieve conclusions that really are meaningless. So it is very important what we were saying.
And actually, just continuing as you were now having the microphone in person, this would have been happening. So what do you think are the challenges in accepting AI, not only from a technical perspective, but more from a sociological perspective? So what do you think that we should be doing as human beings in order, and as scientists maybe, but in order to really have AI accepted in our field? Anything?
I think that at this moment in time, it's actually the opposite. There is an over-acceptance of AI. 10 years ago, if you were trying to do AI and science, scientists will say, I don't trust that. I don't believe in machine learning. I don't trust that. And now everybody is trying to use AI and machine learning for every sort of problem, even if it may not be the right tool. So I think at this point in time, there is an over-acceptance. So actually, we need to be more critical. And of course, think of AI as a very good, very potent statistical tool, but don't think that it's just going to come over and take over the world and change everything that we have founded from science at this point.
Thank you. Nikos, you've been using, I think, neural networks for analysis many, many years ago. So what do you think about this? I mean, what just Trilce was saying about being too much into AI, and we should, as scientists, maybe put some distance. What's your opinion on this?
Well, I think this has been happening lately. I think this turn of focus more towards what people say explainable AI, or focus more on model interpretability is I think what Trisha was trying to say as well. I see it a lot in my field compared to certainly compared to 10, even compared to 5 years ago. There's a lot more focus on robustness and reliability of predictions, and understanding what are the features that a machine learning model is drawing upon to reach certain conclusions than in the past. And of course, there's still more developments in this area, I'm sure, and we're all looking forward to them. I was just going to mention, at least in my field, we are particularly sensitive or interested in incorporating uncertainties, particularly systematic uncertainties. Particle physics is a high precision science. We look for very rare processes or signs of new physics beyond the standard processes that we all know well, and incorporating the systematic uncertainties in the way we train our models, so that we ensure that they don't pick out or they don't rely on properties of the data that we are not entirely sure about, is something that is being worked on very actively, and I can see a lot more of this in the future. And finally, another thing that has been getting a lot more attention is finding ways to validate these AI models with different data sets, with control samples, etc.
Thank you. So another question that is related actually to this topic, and certainly is related to discussion that we are just having, is do you think that there are applications in science or in everyday life that are only going to be possible using AI tools? So a little bit the other way. Trilce, do you have an opinion about this? What is your prediction in this? Only AI? Does it sound attractive to you?
Yeah, I mean, AI has been making such a massive amount of progress in several disciplines. If you think, for example, of AlphaFold, where you can use sequence of proteins to be able to predict the 3D structure of the proteins, using AI, this was done in a few years, when in the past it was taking years and years and years of very slow progress, because the amount of the data, I mean, is enormous for a human or for the traditional ways of exploring the data. So AI allows you to really do a very efficient exploration of the data, finding very hidden statistical patterns. So it is in the biological sciences, in astronomy, for example, finding pulsars or finding rare objects that it is very difficult to find just in other ways. Exploring climate, being able to make a very concise global kind of prediction of how the climate is going to go with the amount of data that we have. So many of these applications, scientific applications that have massive amount of data, they are now relying on AI to be able to make this kind of discoveries, this kind of predictions, just because other ways are just very computationally expensive to do. So yeah, it is really helping in those areas.
Any opinion on this, Francois?
So I was thinking about it just now. So you mean something specific to the field of science, or a task in general?
Can be also general.
So I feel the question is a bit going into philosophy of science, where I would not be particularly expert, but I have the impression that there is no reason that all phenomena are simple enough to be that a human mind can articulate it clearly. So I could imagine a complicated biological systems or complicated dynamical systems where there is no other way than approaching it brute force by trying to do prediction inference with a big AI systems, and you would go really nowhere with a formal description. So now I don't have a concrete example on this, and it's true that all the examples that pop into my mind, it's more that we don't have enough computation power, and if we had infinite computation power, we could go down to a description of the system where we could conduct exact computation and just bypass this. AlphaGo, AlphaFold, all this. At the end of the day, the thing the AI is doing could be done with far more computation. Go, we know exactly where it goes. So I cannot come with a concrete example where there would not be a brute force with enough computation that could do the trick. But more practically, I'm quite confident that there are a lot of things we will be able to do with AI that there is no other practical way to do. So again, simulation of complicated dynamical systems or complicated biological systems.
Thanks. There's a question from the audience.
Actually related to this one, but just the opposite, which is what's the limit of AI and what are the problems that will never be solved by AI?
So who wants to answer on this? The problems that we will never solve with AI.
So for me, all the things that start to look like, the strong AI, this kind of asymptotic thing where the AI would be as. So maybe exactly the question of this panel, which is discovering new law of science, really coming with a compact formula that is a better formula for, I don't know, fundamental physics. this I think is very out of reach of what AI can do compared to what a human brain can do. We can fit big complicated functionals over data, but so far I'm not aware of system able to summarize this understanding into a formula which is compressed, that can be communicated to a human and understood to a human in a formal complex form, like E equal mc square. This so far seems to be out of reach.
Any additional opinion? Yeah, Shibo, you're thinking, I can see that.
That's a good question. I'm looking at it from two perspectives. As a person who is doing some science, there's so much more to discover. And AI is not the one end of everything. It's not the solution to everything. There's more to come. So the aspect of human discovery, the endeavor of human discovery, that's going to continue as long as humans exist. It will be AI, it will be some future things, I'm sure. Maybe AI will change into something. With AI particularly, one area that I see AI still has a lot of catching up to do is, I think AI's got, practitioners of AI, not necessarily AI itself. There is a whole lot to be learned from all the work that has been done in statistics, all the sampling theory, all the work in sampling theory that has gone in there, because ultimately AI depends on data. And being able to supply good data, understanding what the data has captured, and particularly what it has not captured, is what becomes limiting in our applications of any technique, be it statistics, be it AI. Some models that say will work on the American population will not work in Europe because there are confounding variables that were not captured in that particular model, be it statistics, be it AI. So I think that's an area where the science is not so well understood just yet, or there are confounding factors that are pretty large in number. That's an area where AI still has quite a way to go.
Thanks for this. Nikos, please, any additional thought on this question that we got?
I was just going to say you should never say never, but I see AI as a great enabler in fundamental science, as Francois was just saying earlier. I don't expect that an AI model will give you as an output a fundamental theory, but it will help us find answers, solve problems much faster, much better, much more efficiently. At least in the foreseeable future. I can't speak for very, very, very far in future.
Okay, so are there other questions?
Actually, there's one question which maybe goes in the same direction, is does AI will be able to solve or verify theorems, for instance? Could you think of such an application?
I suppose empirically, much like we discover new particles these days, which is experimental physics. Maria can think a lot about that.
Nikos as well. So can we use AI for discovering what we don't know?
I think it depends how you think of this, but people do work on ideas of building models that for anomaly detection in the atlas data, looking in a very inclusive and non-prescriptive way. Although you do have to fit in these models all the knowledge that we have so far about the processes that we know about. But there is this expectation. I think this goes closer to and it's the most relevant thing that I can think of to relate to that question. There are people that think that you can then expose the full data set from the LHC and just find in a more, if you like, unsupervised way, some deviations from expectations that you wouldn't otherwise be able to see.
Would this apply to medicine, Trilce, in your opinion? Just a provocative.
Yeah, right now there is a lot of work trying to do something called, for example, generative modeling. In that case, they are trying to have the AI to come up with the theories based on the data. So if you think of it a little bit as probabilistic, so what is the theory that better explains this data? And it applies to all of the sciences. I don't know how far they are going to get. I think this current started around 2016, and they are making a lot of progress in the explainability and the causal relationships of data and these models. But probably we're going to make very good advances in that area. I couldn't predict how much or how wide this could really affect things, but it's a very interesting type of work.
Yes.
So to come back to the question, which was theorem proving. So there are some results recently about you would train a deep net to do integration. So because you can compute derivatives formally, it's easy to build a big training set where you give the network the derivative and you ask it to repredict the original functional. And those things works amazingly well. So it's surprisingly efficient at doing this. So here we start to see an embryo of formal reasoning, because we cannot dig into the weights to understand exactly what it understood. But at the end of the day, if you give it a functional that it has never seen, it's able to compute formally the primitive. So I guess theorem proving would be in this realm of formal manipulation, even though the underlying process to the formal manipulation is, again, a deep net, which has no understanding in whatever sense it means. But I could imagine that there are systematic algorithms to do theorem proving, so it's something that can be done formally, like also proof of program, verification of program. And I'm not an expert, but this seems to me to be very close, again, to tree search for a strategy game. So I would not be surprised if, in the near future, and again, maybe I don't know the published work in this field, so I would not be surprised if it was already existing. If deep nets combined with this kind of tree search would give this kind of layer of intuition of where to go to find the proof. So again, this does not seem to be completely out of reach for the coming years, theorem proving and formal manipulation of mathematical expression at a higher level.
Thank you. We continue with and we change the topic a little bit. So I would like to bring on the table the topic of sustainable AI. So it certainly is driving computing development and computing usage. So how do we calculate the impact and the hidden costs of AI? And maybe I would like to start with the hidden costs. How do we assess the cost and benefit of AI tools and decide what techniques are the greenest? And I wanted to ask this to Nikos, because maybe you have some thoughts about this area in your experience in data-intensive science and the doctoral students. Have been thinking about helping us on this part of the problem?
Not yet, I have to admit, but I have been thinking, and actually certainly in my field, in big science like experimental particle physics, there is a growing concern or a growing awareness of the sustainability aspects of doing research in general. So this is something which is I would say it's rather new in our area, as far as I know, in research more generally, but it has been happening. And I think there is a lot to learn from maybe industry sectors, from other sectors who have been including the environmental and sustainability considerations in the overall project costing or project management. I mean, of course, in research, one might argue things are more complex, or there's a different perspective compared to commercial activities or commercial development of products. One argument one could say, well, if AI helps you to achieve a certain level of some measurements with a level of precision that would save you from running the experiment by 1 or 2 years over the lifetime of these large experiments, I think that is something that has to be factored into the overall cost. Yes, it does. You spend a lot of time, a lot of computational power, a lot of energy in producing these models. But in the end, in the lifetime of an experiment that runs for 5-10 years, now more, it's possible that overall there is some efficiency and economy in the end.
Yeah, and talking about computing power, and are we worried that there is too much computing power and attention focused on AI? Ejibo, what is your take as you're coming from Oak Ridge National Laboratories? Is this something that people think about? Are you worried about this?
I don't think I'm worried per se. However, it's well understood that, as you know, Oak Ridge National Lab has housed at least one really big supercomputer for decades now. And every 2 to 3 years, there is a new computer, which means that there's a construction of a computer going on always. Early on, we found a lot of energy efficiency coming from using GPUs, and it being able to pack a lot of computational power and giving us the flops. Now, AI also happened at about the same time, and AI is just so suitable to be run on GPUs. And so the computing effort here and several other places has focused quite a bit on using GPUs to deliver that horsepower. And so when we had Summit, which is a pretty big machine right now, it is also pretty high on the green scale, and green scale in terms of how much energy it uses for those flops that are being computed. It has been used heavily for AI-based research, and the new machine that is being built is going to be also heavy on GPUs. And one of the key challenges here has been to make sure that that computing power can be delivered with a reasonable increase in the amount of power it may draw. Now, that's one end of the science, something that Nikos was talking about, which is high volume, high data, high compute. There's multiple aspects to this computation. When you have data and a lot of it, it's not just the GPU that's consuming power. There's this data that needs to be staged and data that needs to be pushed into these systems. So there's a cost to that entire process, and a lot of this data in AI can actually come from observational systems. So quickly you're looking at the edge and the cost of having some inference that's being done at the edge processors. That becomes particularly acute, for example, in our smart cars. It runs on a battery. And if it has to make all those decisions from all the LiDAR and the radar and the camera data on board, it's going to drain out that battery very quickly. So I'm seeing a lot of innovation and a lot of focus that is actually happening on a lot of these edge devices on how do we get to become really power efficient with those. And I'm pretty sure a lot of those techniques and strategies will come about to facilities that are more physical and wired. That's about to happen. I do think there's another angle of the sustainability, the churn on these devices. What happens to the devices in a year when they're obsolete? and we need a newer device to get the latest and greatest. There is a cost of the life cycle cost of that as well that we are becoming more and more aware of. And that's a good thing. So I'm pretty confident we'll get there in terms of having the processing and the technology to deliver the insights and the science from AI. Will we want more compute power? Oh, yes, always.
Thanks. And related to this, actually, where would we be investing to reduce the carbon footprint of AI? On more efficient hardware, as we were just discussing, or in fact on researching smaller, faster, more efficient models and optimization techniques? I think you have been spending some time thinking about all this, Francois. Yeah. Where would you invest? What is your recommendation?
So I would invest on everything, because I think any ways of cutting on the cost of the energy cost of AI will be a good thing. I think so. I agree with everything what was said before. But to summarize, so there is first a fundamental vexing thing, which is a brain is basically 20 watts. So there is something very bizarre here, that 20 watts of gray goo is able to do far more than hundreds of megawatts of GPU. So there is a fundamental question to ask, even without thinking about environmental issues, simply as a fundamental question that we must be doing something wrong. There must be something that should be rethought from scratch. And now regarding the algorithms themselves, so the situation currently is a bit, I was thinking also about the similarity with this fundamental physics. So you guys are making bigger and bigger accelerators. So on the AI is a bit like that. The bigger the model, it's a bit sad, but the bigger the model, the better it works. So we still see this. We still have not reached a plateau for language models, for vision models, where we can say, okay, now it's useless to burn even more compute power, because it does not help. It still helps. So you have these power laws where every time you increase your computation power by a factor of 2, you improve your performance in terms of loss and validation set by something. So now, what is the best direction to do? I would say there is obviously a class of algorithms that would prioritize computation more, so that have this. The big craze at the moment are those attention models, which dynamically decide how to reweight features in intermediate representation. And there seems to be particularly fitting to having prioritization of computation, so to decide not only how you weight stuff, but what are you going to compute next. And this is not a standard way of doing things. There is no currently a standard algorithm that does this, so there is probably a lot to do there. And otherwise, maybe something more fundamental. Again, we seems to be missing something the brain is doing well. Maybe robustness to noise. It's a bit bizarre that we have those fancy GPUs which come from the history of computer science, which really looks for exact computation, exact float computation. And in AI, you don't really care. If the computation were a bit dirty and some of the bits would not be correct, it would be hidden in the noise. Your data are already noisy. You don't really care. So there may be also a mismatch between the kind of technology we use, which was designed for other means, really for exact computation on the crypto, on the exact simulations. Or maybe you could afford a bit more mistakes, a bit less reliability in the hardware. As far as I know, it's not something even companies specializing in AI are looking at. Google TPUs, for instance, or NVIDIA GPUs specialized for AI are not specially designed to allow for mistakes at the cost of, not throwing away wafers, for instance. You would, every time a chip has a mistake, you just throw it away. Maybe we could keep them and use them as that. So a lot of things to be done, I think.
Very interesting. Are there additional thoughts on this?
What you touched upon was excellent. We know traditionally between FPGAs and ASICs, there is a huge energy use difference because one is just more specialized. So if you can narrow it down where it is flexible just enough to our needs, but still design the hardware that serves the purpose, we can save a lot of energy.
Well, I was just going to add one more thing, which was training, but more training for the young generation of AI practitioners to learn or the state of the art in terms of tools for optimizing the various models and achieving the efficiency or choosing whatever model is the best for the problem that they have and achieving the most efficient results in terms of training.
Yeah, that's a good point, too. Thanks. Are there questions from the audience?
There's a question about ethics, but I think you might probably...
No, maybe let's go for that.
Okay,
yes.
but that's the question is, should we discuss the ethical aspect of AI? So, no precise question, but just a very general one, which I think is an important one.
Who wants to address this topic?
Can I just say we started talking about the ethical aspects because the sustainability and the environmental aspect are part of the overall topic of the ethics and the sociological impact of AI. But on the ethical side, this is a very long conversation. It's to do with biases and of course biases have different impact in different depending on which area an AI model is applied, and again for me a lot of it goes to the training of everybody who's using the AI algorithms. I mean, the more powerful the tools you have to analyze your data, the more aware you should be and more careful you should be about how exactly you use them.
So about then continuing on the biases, then is there an opinion? Trilce, Gibo, Francois, you want to add on this? Trilce, you want to start to continue?
Yes, biases definitely are one of the important aspects in AI. One of the projects that we worked on was trying to help, for example, researchers to figure out if they could remove contextual biases from their problems, specifically in forensic analysis. And the first thing we discovered is that AI was going right straight for the biases. It was looking at gender, it was looking at race, it was looking at all those things that the researchers were hoping the AI was going to be able to remove. And that goes a little bit also back to the ethical consequences, because if we are not aware of all these things that are depending on the quality of the data, if the data itself has been collected in a way that is already biased, the AI is just going to learn that and is going to magnify all those little biases. So it is very important that we pay a lot of attention, and that has been mentioned before, to the data itself, to be able to have statistical ways of analyzing that our data is not already biased, because then the AI is just going to magnify that. And just to add into the ethical considerations, sometimes we as researchers, we are just trying to build our systems, like for example, facial recognition, or nowadays the main generator of data is personal data. So you have systems that follow your Wi-Fi use or follow your mobile devices, and all of that in the name of research, but it can also be used by surveillance purposes in a way that really restricts your rights as a citizen. So it's very important to, as a researcher, to question yourself how the things that I'm working on could be used or misused for other purposes.
Gibo, you want to add on something on what has been said?
Sure. I think you can touch upon something very fundamental here. So if you look at how we interact with our environments, we want these services for ourselves. We want a better experience in our day-to-day life. And we do not want to share our data. And we are concerned about our privacy. So we expect that the system is going to optimize or do something at the system scale, give us those really energy efficient cities and so forth. And in the process also delivers us an individualized, optimized experience. And there's a balance there and how much we're willing to share to get that kind of something back from the system. And then at the system scale, there is the onus of protecting this information and ensuring that those suggestions and outcomes meet the highest level of ethical standards is of paramount importance.
You want to add something, Francois, on these points?
Those are very open questions. So the question about ethics, should we take care of the ethics of AI? The answer is yes. But there are I guess I share the opinion of the other panelists. There are so many topics. On just the bias, the point of bias in itself, it's such a complicated problem because when somebody shows you the bias, so we have this atrocious example of language model, for instance, where if you ask a question about men, you would have a kind of answer, and if it's about, so the standard will be, I had this for another conference, I run a few examples on so a language model, you can start a sentence and it will continue it for you based on regular statistical regularities. And the beginning was, for a man to be successful, it has to, and then you let the system complete, and the completion was something like, to be the best in his skills. And if you write, for a woman to be successful, she has to, and then it was to be a wife at home, or some atrocious things like that. And of course, because the corpus was something from the 50s, the 40s, the 60s, people had trained their language model on those things from the US in the 40s. So you get this kind of bias. So when you see this kind of bias, of course, you're like, okay, that's horrible, it should not happen. But I'm always very concerned about all the bias that we don't see, and that we have biases. So the AI system will always have biases. We can probably deal with the one that get in our face, and obviously we should not do this. But I'm very concerned about the one that are deep in there, and we will never have any way. I'm a bit pessimistic about this. So I'm very pessimistic about the ability to even define what is a proper training data set. To say I'm going to be very careful when I collect my data, I'm not even sure this can have a precise meaning. There can always be biases and hidden aspects that you have no way of figuring out. So I'm a bit pessimistic for this, to be honest, but we will see. Maybe I'm too pessimistic.
Or maybe not. Are there more questions?
A few more technical ones, but maybe I have a general one from myself, if you agree. So I was wondering to what extent AI may prevent us to think, because we have already, several results that our memory is much less than it used to be in the past, because we rely more and more on devices to help us to memorize things, so we don't have to put that in our head anymore. Now AI is basically producing results. And the way it's done, I mean, what we said, it looks like we can just rely on this AI system and we don't have to be critical anymore. So do you see any danger about this trend, or you think it's just not going to happen and people will still remain critical and still try to build in their brain, models and try to understand what happened?
Let's face it. Teresa, you want to have a start?
Yeah.
Thanks for the question.
Thank you for the question. Yeah, I was just trying to think, because it is unfortunate. I mean, the culture right now in AI, if you look at many websites, you see something like build your AI in 10 lines, or build your neural network in less time than it takes you to bake a pizza. And that's part of the culture that is permeating right now also in science, where people are like, okay, let's just download one of the frameworks, and let's try our data through all of that, and let's just figure out what it comes up with. But that's a very dangerous thing to do, because of course if we don't look critically at all of the other aspects of empirical research, then we are going to end up with a lot of mistrust also eventually in the AI. So we are going to say, okay, right now we are at the peak of using all these tools, and then eventually when they don't translate into the real world in the way that we expect them to, we are going to say, oh, these tools don't work, don't trust them. And it's not really that they don't work, it's that if you don't have, you don't use a strong empirical research to come up with results, then they are not going to generalize outside of whatever limited amount of data or whatever limited input that you gave them. So it is, and I forgot the other part of the question, I'm sorry. But just to say, it needs to be a change in culture in how we are addressing this, how we are using these type of tools. Just make sure that that you are very rigorous in validating. It was also mentioned before in the panel. We need to be able to reproduce our results. We need to be able to validate with methods that are not already correlated with the AI that we were using to make initial predictions. So if we can get there, then we have a brighter future into being able to generalize outside of whatever limited amount of data or whatever limited conditions we use to build original models.
Thanks. Francois, do you have an optimistic or a pessimistic view on Bastien's question?
So Bastien is concerned about atrophy of our brains because we have prosthesis. So I think there was a text from the ancient Greek about people starting to write too much, and it would make their brain less efficient because they could have notes of what was said, they would not have to memorize it. So I don't know how much it's the same level of concern, or actually, you know, the symbiosis between human and AI it will just make us smarter. It's just like having a pencil and doing math instead of doing it in your brain. You use a whiteboard. Is it this kind of interoperation? But unfortunately, I'm not that optimistic, and I tend to believe that there is something true. So again, with language models, with generative image models, and all those things, I think it will be very easy. And it's a bit what we see with filter on Instagram and this kind of stuff, where you can, some things that do not meet certain criteria, and without effort, you can make them meet certain aesthetic criteria. And I'm curious, for instance, again, with language model, to see what's going to be the future of writing, given that those things will be able to write beautiful text for you. So you will give some bullet points. Oh, I want to write a love letter to somebody, and poof, it will directly, you would give some vague points, and then it will write the perfect letter for you. What is the status? What will be the status of human production, intellectual production, if something can mimic it so beautifully that it will be perfectly fine and will be happy? And same for photography, same for many things. So again, I share this concern that it may be a bit, it can be a bit discouraging that if you do it the hard way yourself, you will get something far less beautiful than, in a very general sense, whether you're doing math, literature, photography, art, maybe cooking if you have a robot or whatever. Even doing it the right way, the organic way, you will be put at disadvantage compared to people using those prostheses all the time. So I don't know, I'm pessimistic again.
I'm scared. You have a more positive view, Gibo, Nikos, to share?
But I would say we have to. I think what Bastien was saying is from the perspective of users of AI algorithms. And so I would say we have to make everybody we have to train people to be developers or understand how AI algorithms work and make people developers of AI algorithms. And that will make us, certainly will make people more intelligent. But you know, there is a question of scale of how much you can achieve that. But that's something we should be trying.
We go to the last question, maybe?
So, I mean, there are one technical question about what you said, Nikos, earlier about uncertainty in AI, and the question was, is there any tool that can, provide a probability distribution of your output? So, I don't know if you want to comment on that.
I'm not aware that there may be. I'm not aware of any such tool. But we, as I said, this is an area of active work. In fact, in just a few weeks' time, we have in my experiment Atlas, we have a dedicated workshop on how best to incorporate uncertainties in the training of our AI models.
And just a question now, whether there are methodology to evaluate the impact of AI on our society. I mean, can we measure, or is there any metric that say if it's positive or negative?
Gibo, you want to tackle this?
I can talk about how we are doing it. To understand impact, we need to be able to measure. Impact of anything, we need to be able to measure. So what we try to do is approach and identify certain processes that we are looking to improve, identify what their baseline operations look like, and then say we apply a methodology using an AI technique that improves or is expected to improve it at a certain operational scale. It could be a minute to minute, or it could be at a higher time aggregate. If it ends up improving those metrics, at that point, yes, we are successful. But I guess in the vein of the whole discussion today, we also look at other anecdotal evidence. So how are the other people experiencing it? Are there things that people are experiencing that is more negative than what it used to be? Because maybe that was a confounding factor that was not included in our algorithmic design. But that's the approach we use to see the impact to that baseline at operational scales.
Anything to add?
So there's a comment with respect to the discussion before, and someone saying that we were too pessimistic about the atrophy of our brain, and saying that actually industrial revolution and everything shows that we're actually progressing and we become more intelligent in some way. But the question is there a limit or not? We'll see. But I think it's interesting to see that people are optimistic and think that we will always find ways to improve. Nikos agrees.
We should close on a positive note. Please.
Indeed, I mean, look at our ancestors, or just the last 5 generations. It's not that our generation is the smartest among the last 5 generations or earlier. So, yeah, I hope we're not getting dumber.
What do you think? We can leave it on a positive side and the hope that we are becoming more intelligent.
Exactly.
Indeed. I mean, going up that value chain.
True.
Okay. So I guess we will close here.
Yeah, I think that it's time to close.
Yeah.
So,
and let
from my side, and then I leave Bastien concluding. Really, many thanks for having been wonderful panelists today, and I think that it has been a very good hybrid exercise, which brings us to a positive note of doing something in person very soon. And I leave to Bastien to close the session.
I just want also to thank you all to share your opinion and the great idea. I think it was a very exciting moment. Of course, I'd like to thank Maria for organizing all this and preparing this question. I think that was very nice from you, and we appreciate.